create and implement security solutions for his clients. Over the course of his career, Micah has led teams both big and small across startups and large financial institutions. This workshop will focus on Terraform implementations and ways a malicious user could abuse them. During the workshop, you'll all learn how Terraform works, how Terraform security controls work, and multiple ways to bypass those security controls to gain further access to environments. So everyone please give a warm welcome to Mike. Thank you.
Cool. I also told him I'm 7 feet tall. I didn't mention that, but you should know that just by looking at me.
We'll get it in the post.
Okay, thank you. I paid $20 for that, so. Thank you all for joining. This is a packed house. I'm honored that everyone came here. If the talk/workshop sucks, at least you have a seat to sit in for the next hour or however long you want to hang out. So this is infrastructure as remote code execution. Can you guys hear me okay? Cool. So we do have a few labs. You don't have to do the labs. I'll be doing demos, but if you have a GitHub account, just sign into it now. We use code spaces. The Wi-Fi is not amazing, and code spaces takes a little bit of bandwidth, but if you want to follow along, you can look at the code. I'll show you the link shortly. So about me, again, 7 feet tall, as you can tell. So I'm Mike McCabe. So I run a boutique cloud security and application security company. So we work with a lot of companies, small and large, from Fortune 20s to 30-person startups, helping them build cloud security and application security solutions. So we've done a lot of of rules and different languages to help kind of secure infrastructure as code. And the reason why I think it's such a great thing for security practitioners to learn, both red team and blue team, is you can build a program around Terraform or whatever you use, CloudFormation, and bring your security findings down to maybe not 0, but way, way less than what you're at before you do it. So it's a very powerful preventative control. So what does it generally look like? This example is Terraform Cloud, but infrastructure as code pipelines don't look that much different than app CI/CD pipelines. A developer commits code to a repo, GitHub, or GitLab, and if you're struggling in life, Bitbucket, no offense, for Terraform. It's a stateful product, and I'll kind of talk about what that means. But when you do deployments, you do two things at first. Terraform plan is where a lot of the magic with Terraform happens, where you're building these huge trees of resources and they have interdependencies. If a S3 bucket relies on an SQS queue to be created, there's a dependency there. And so some of the magic that Terraform does is create that dependency tree of saying this needs to be created before that, so then that can be created at the output of that. And that's kind of the magic and how it makes it much more simple to create infrastructure with Terraform. So the plan is pre anything getting built. So nothing gets stood up in the plan. But there are some tricky things in the plan that I'll kind of get into. One of them is unknown values, because you can't know something before it's created. You can't know an ARN before the resource was created. So it's just keep that in the back of your head. And then when you're ready to actually do the creation, Terraform apply takes that plan, reaches out to the cloud provider, it creates, it updates, it destroys, whatever it is in your environment. And then it updates the state file, which again, it's stateful, so it keeps track of what you have out there, and it updates the state file. That's a representation of what you have in the environment. So what does Terraform look like? This is all you really need in Terraform to create an EC2 instance. AWS instance is just an EC2 instance. You define a couple of things, a provider, which I'll talk about in a second, an AMI, the image, the size. You don't even have to have tags. You can just skip that. But this is all you need. If you run Terraform plan and apply on this is going to go out to AWS if you have credentials and set up an EC2 instance. So it's not very complex to get going, which is great. And then what does that plan file look like? The plan file is actually in like a binary format, but you can export it into JSON. And so you can see, even though our Terraform is very simple, in the back end there's a lot of attributes that are either set to default values or they're set to values that Terraform chooses. And if you have a security eye, you can already see some things here that look interesting in this plan file. Get password data is one. So these plan files have a lot of details about how things are going to be created. And a lot happens even if you don't choose the attributes for the resource. So getting into kind of the first lab, which is a really basic demo. If you have a GitHub login, log in now. People familiar with code spaces, it's hosted VS Code. This instance has access to an account that has EC2 access. Please don't be a dickhead and tear everything down. Don't be that person. So if you can read that, that's the GitHub repo. The bit.ly link is to the same URL. It's not like my PayPal or SoundCloud or anything. So I'll give you guys a second to log in if you want to take a look at that. Once you're logged in, you open Codespaces, and you can open a terminal in Codespaces. Any folks working through this, or should I just do a demo? I see phones, but no hands.
There's
demo.
computers too. People don't.
Okay, I'll give you 30 more seconds to write that down.
You should probably have your timer going, because how are you going to only spend 30 seconds?
Amazing memory.
Decide if I can 7-foot stature.
Yep. All right. Can you all see that? Yep. Nope, it didn't switch. All right. I know this is a little scrunched, but can you all see this? Okay. Of course. Yeah, everyone please stop streaming Netflix right now. So, if you can see this, basically what we define is a basic AWS instance, and we're also creating a secrets manager secrets version, which is just part of that, and a random value at the end. So let's see if this actually loads, or I might need to tether. This works better.
It is tethering now.
Of course, demos never go well. Big Chungus, can I use your... Alright, well, if this doesn't work, I'll try to do it at the end, but this is definitely moving slow, so... I can always show you... I can show you some basics of what things would look like, so... Actually, this might work too, because... Yeah, the Wi-Fi doesn't work. Yeah, I can actually get the Wi-Fi working.
Yeah, nothing's going to work if the Wi-Fi doesn't work.
There was.
Yeah, I'm on the conference Wi-Fi, but I think it's just going super slow. Anyway, so I'll go back to the slides and we'll come back to some of the demos. Alright, well I'll try to come back if the Wi-Fi starts working and do more of these demos. So I kind of mentioned the Terraform state file. So it represents what you just created, what you updated, what you deleted. It's basically a representation of what is out there. What's interesting about it is it's used to manage your environment once you do something in Terraform. The other fun thing is it holds all of the secret values that you create through Terraform. So it's something people don't think about when they use Terraform is if you're creating secrets, even if you're creating an RDS instance that you're creating a master password for, it's going to end up in that state file. So here's an example. I don't know if it's kind of hard to read, but this is a Terraform state file where we have a secrets manager secret. I would not recommend creating secrets via Terraform. You should have an out of the pipeline process for that. But this is if you create this, it's going to end up in your state file. Any red teamers here? Handful? Yeah. So if you're on a red team and your company uses Terraform, definitely look for wherever they back up their Terraform state, because you can find these secrets. There's a good article by Sysdig. They did an investigation for a client, and their client was hacked because someone got a state file. They used that to basically pivot elsewhere into the environment. Sorry, where's the HashiCorp person again? Sorry to call you out, but HashiCorp is aware of this issue, and I love this image because if you can read the top, this is a GitHub issue from 2014, and so someone basically said, how do you deal with sensitive values in Terraform state files? And the last update when I took this photo, which was a couple months ago, was 20 hours ago, and it was a PM from HashiCorp saying, yes, we're aware of this, yes, we're still working on it, we don't have a solution for you. So sorry, Omar, for calling you out. Hopefully you're not the person who's here, but HashiCorp is aware of the issue, but they don't have a good solution for it. And a lot of people create kind of hacky solutions for this, but the best thing is to try to deploy as few secrets through your state file as possible. So we have one obligatory meme that we have to show. Yeah. So I have another lab, but I'll get back to that in a second if the Wi-Fi starts working. So another big part of Terraform is providers. So Terraform, the language is just a very basic language that gives you those, plan, apply, state management, things like that. But if you actually want to do something in an environment, you have to have a provider that basically is the API to those, cloud providers or anything else. It doesn't have to be a cloud provider. It can be a lot of different systems. And so HashiCorp themselves have, I think, maybe 100 providers that are official providers. Then there's thousands and thousands of providers out there that are available, off GitHub or wherever else. These are some of the official ones from GitHub. So you can see they have, AWS, they have Azure, they have a lot of different smaller providers. But these providers, like the AWS one, are, I think, probably 1 million lines of code for some of the big ones, and even the smaller ones are still huge code bases. So when we start using these providers, it's just like NPM libraries, it's like Python libraries. We're introducing a huge amount of code that we trust, and we're also running this code in our CI/CD pipelines. So that means that we're bringing in third-party code, running it in our CI/CD, potentially giving it high privileges, and there's no way we can review all this code. You don't know if something malicious got pushed into this. You would hope that HashiCorp has, strong processes to make sure that no malicious code gets put in there, but you don't actually know that for sure because, as I showed, they're not even great about handling secrets. Again, I apologize to the HashiCorp person. So we've seen people, there's been a few cases of people publishing malicious providers, there's been cases of people downloading sketchy providers, so it's another thing to think about when we talk about how do we secure this whole stack of Terraform. My recommendation is to limit the number of providers you can actually introduce, air gap your install, make sure you can only pull from kind of your list of providers that you want to be used. Another piece is if you're using something like Terraform Cloud or Terraform Enterprise, there's a whole set of APIs to manage those systems. So if you don't manage those properly, you can do things like run plans, update Terraform plans. The thing that scares me probably the most about this, and something you have to think about in Terraform Enterprise and Cloud, is there are APIs to update your state file. And the state file, again, is a representation of your environment. So if you can update that state file and then use it to make updates in the environment, the case I always think about is if someone was able to do an import of all your RDS instances in your production environment into their state file and then just delete everything through Terraform. So just imagine someone importing all of those, running Terraform destroy, and just deleting everything at once. And these APIs are a little open when you first set them up, so you have to make sure that you have those locked down pretty well. Another thing to think about, Terraform logging. So you can kind of see in this, but when most Terraform implementations, if it's Terraform Cloud or Enterprise or sometimes CI/CD, they're going to assume a role, an EC2 assume role from that instance into whatever role you're going to use for production. When it does that, it outputs the access key, the secret key, and the session token. And so if you're a developer or a malicious user, you get access to a Terraform workspace. You run a plan, you turn on TF log, which is just an environmental variable, so it's not a privileged setting you have to turn on. You turn on TF log, you set it to debug or trace, and that's going to dump out those credentials. So they recently addressed this. For some reason, sorry again, HashiCorp guy, for some reason they chose to blank out the access key at first, which you can see there, which makes no sense because you can find that in CloudTrail, instead of blanking out the session token, which is ephemeral. So they've addressed this somewhat, but if you're running an older version of Cloud or Enterprise, then this is still an issue. So if a developer can turn on debug logs, they can dump out that credential, use that privileged role to access things. So one more thing to think about. So I like to say that Terraform is for use by competent persons only, and I always like thinking about the story behind why they had to add this label to this, because this is a voltmeter to check electrical outlets. So we'll talk about some of the techniques that we, kind of in the work we've done, we've discovered that allow remote code execution or just kind of bad things in Terraform implementations. I don't know if the Wi-Fi is working any better for anyone. Is anyone able to load the code up? No, too slow. That's crappy. So these are a few techniques. I can't cover everything, so there's a lot, but these are just a few that you should think about. So Terraform is an infrastructure as code tool, so it's meant to provision your infrastructure. It's not meant to provision, OS. It's not meant to provision your application libraries. And even Terraform says, we care about the infrastructure. We don't do things with the operating system or the software. Use other tools like Ansible, use Puppet, Chef, whatever it is. But for fun, they give you a way to do it anyway, and people use this pretty often, and it's an anti-pattern, but people do it. So remote exec is a provisioner, which basically, when you set up something like an EC2, it will run after the fact. It connects to it, runs after the fact, and runs whatever script you want to run. So it introduces code, not Terraform code, but Bash or Python or whatever, into your infrastructure deployments. And the line at the bottom is from HashiCorp, and they say it adds a considerable amount of complexity and uncertainty to Terraform usage, which is very great and very couched language. So here's an example. Can you all read that okay? So basically, we're setting up an EC2 instance. We have a connection to the EC2 instance. And then once that's set up, we run a provisioner, which is remote exec, to, well, I guess I can ask people, can anyone see what that does? Anyone know what? I didn't get that. Netcat? Get him a sticker. It was the first person I heard. I know you all shuttered out, but I couldn't hear you. Yeah, so this is basically a Netcat app. So I know for startups and smaller companies, you might think that it's not that big of a deal to let people do things on servers. Like, we trust our developers, they run software on our machines. But if you work in an environment where you're under like SOX regulations, people can't have production access, and so people can't just SSH into production servers. You have to have a privileged access management, which means change control, things like that. This is kind of a big deal because you can just bypass all that stuff. You can create an SSH key, you can set it up in this, you use remote exec, run whatever you want on that. So you could use it to tear off all your endpoint software, and then in this case we're netcatting out to say a C2 server, something like that, so that you can do more in the production environment. Then another technique, local exec. So similar to remote exec, instead of working on the endpoint like your EC2, local exec runs wherever Terraform runs. So a lot of folks, if you're using Terraform Enterprise or Cloud or just Jenkins, like I said, it's going to assume a role and then do things with that role. So similar, it's a way to run code. It's also an anti-pattern. HashiCorp again says don't do this. Provisioners are a last resort. But it's out of the box, it's built in. You don't have to run a different provider. This is just part of their code base. So in this case, I like this example. It might be kind of hard to see, but you can use local exec. Again, if your Terraform user has admin access, and every developer only has read-only access, as a developer, I can basically use local exec, this is curling the STS metadata endpoint on EC2. People familiar with that, basically? It's the way that assume role happens. So you're curling that, you're getting those temporary credentials that I showed in that log, and then you're curling that out of the environment. So the idea being, you can use this to grab those credentials, send it out of the environment, use that assume role somewhere else. So it's a pretty powerful way to do that. So this actually worked on Terraform Cloud for a while too, where you could actually get the STS credentials from Terraform Cloud, but they fixed that on the metadata server recently. But there's a lot of other cloud products out there, so give it a shot and see. Let's see if the Wi-Fi is working.
You want to try using a different hotspot?
Yeah. Well, I'll want to try to connect. I didn't see that. Yeah, well, else connecting to the conference Wi-Fi, so we'll see if this works. I'll keep going on the presentation. So, are folks familiar with semgrep? Anyone? Really? It's Ansible? Yeah. So everyone knows what grep is, hopefully, unless you're a Windows user. But semgrep is semantic grep, so it's basically a tool to kind of enhance the pattern matching of grep, add more metadata, add more capability. It's an open source tool. There's a paid version, there's a cloud version, but you can get started with it just using the open source tool. So it's basic pattern matching. It's pretty fast. You can integrate it with pipelines very easily. It's free, which is always nice. There's a lot of open source rule sets, which is good as well. So if we want to prevent some of these things, it's actually pretty straightforward to do. So if you have a CI/CD pipeline, if you guys are already doing SAST on your app code, you should integrate something like this into your Terraform code as well to prevent kind of some of the things we talk about. So this example is on the right, we have some Terraform. It's using the local exec provisioner, and then on the right we have a rule. And that's the zoomed in version. So the nice thing about semgrep compared to a lot of SAST tools is they're very easy to get started. This takes 5 minutes to write. So you basically define a pattern. In this case, we're looking for anything that says provisioner, and then any provisioner we're going to fail on. We're going to look inside Terraform files, and if you run this in your pipeline, this should fail if it finds Terraform running using provisioners. So the nice thing about this is Terraform is pretty simple language. There's not a huge amount of complexity to it. And so you can write semgrep rules to prevent a lot of these things.
You can also use sentinel policies.
I'm going to get there. You're like 5 slides ahead. So Terraform is also a great way to gather data about an environment. So if Terraform, even if it doesn't have write access to everything, if it has read access to it, you can do a lot of damage that way too. And there's also some interesting techniques you can do that are technically data methods, but aren't really. So in Terraform, there's resources, and then there are data resources. So resources would be like your EC2. A data resource is, it could be static data like an IAM policy that you want to create. It can be an SSM parameter that you're calling out and getting the value of. There's also a couple other interesting data, again, in quotes, data methods that they have built in that you can use to kind of abuse the environment. So the HTTP data method is actually just a data call that does an HTTP GET. It's very basic. It doesn't do post. It doesn't do headers, all those kinds of things. They might enhance it at some point, but for now it's very, very basic, which is good. But the bad thing is that if you don't have IMDS v2 turned on for your metadata service, you can use this to basically hit that metadata service, get your SCS credentials again, dump those out to your log files, and use that to pivot. And this is just, again, a built-in method that's in Terraform. You don't have to do anything fancy. So, kind of demo, you can see you run a Terraform plan, and it's important to know this runs at plan time, not at apply time. And you can see it dumps out those SCS credentials. So again, the solutions for these things are super simple. A simple semgrep rule takes 5 minutes to write to prevent this kind of stuff. So it doesn't have to be complex to make this work. There's some other techniques as well. So external data, again, it's called data. It's a data resource, but it's actually a way to run code. So you can define bash scripts, you can define Python scripts, you can do quite a few different things with external data. It's another built-in method. But in this case, what we're doing is running a Python script named exfil data, very descriptive. And so what we can do is call a data resource, which is a secrets manager secret, and then basically pipe that into the Python and use that to exfil. So again, even if you block local exec, if you block remote exec, you have another way to basically run code in your Terraform pipeline. And again, some people say, well, our developers have very wide access, and this might not apply to the 30-person startup that has no security controls. But if you're a bank, if you're well-regulated, and you don't allow your developers to run code, this is one way to bypass that you have to think about. Yeah.
The Python has to be loaded on the Terraform host?
Yeah, but you can just put it as part of your Terraform code.
Okay, but the same token, you can do something malicious with it. You can also do something security positive with it, right?
Yeah, you good?
Okay.
But then you're introducing Python into your Terraform environment. So we try to avoid that. So those are the security controls we've showed so far. Are very basic. SemGrep is you know, it's a great tool, but it's very basic. It's not a full, I would say it's a full SaaS tool, even though it's getting more and more fully featured. So if you want to do more logical work, there's a few different tools you can use. So someone mentioned HashiCorp. They have their own tool called Sentinel. It is a paid tool that's part of the cloud and enterprise instance, so you have to pay for a license for it. There's also OPA, Rego. Are folks familiar with OPA, Open Policy Agent? A little bit, yeah. So Rego is the language that's basically created to do a lot of similar things as HashiCorp. It's meant for validation. It's not just meant for Terraform, but it can be used in a lot of different areas. But I'll talk about HashiCorp Sentinel because they're paying me to. No, I'm just kidding. I wish. So if you want to do something a little more complex than just a pattern matching, you can write still pretty basic Sentinel. This is 16 lines of code with white space, so it's not overly complex. But if you wanted to do something like we're going to only allow certain EC2 types, you write a simple rule like this that says, all right, define a list of allowed types. Plan.find resources looks at your plan file, looks for everything, all the EC2 instances that are there, does basically a comparison of that and the instance type against your allowed list and fails if not. So very basic example, but you can extend this to do pretty much anything. You can extend this to be AMI versions or just about anything that you can reason over you can do in Sentinel. That's a basic example. You can do things like enforcing a role that you use. So in this case, we're enforcing a role that we want to be assumed. The provider is what assumes the role, so you can look at what role it's actually using, and then look at your Terraform plan and config to say if it's allowed to assume that role. So Sentinel is if you want something a little more fully featured to do more logical, or like more code-based rules around HashiCorp or Terraform, you can use something like Sentinel or OPA. So, I talked about this a little bit at the beginning, but what are some ways you can avoid these tools? So if you run a tool between the plan and apply, so the plan is going to say what's going to be created, the apply is what actually goes out and creates it. There's a couple issues. So one is all those things I talked about that are data calls, those are all run at plan. So if you want to go hit your SSM parameters or your secrets manager, you can run a plan and that pulls that data in then. So if you put your security controls after the plan but before the apply and you say, okay, well, yeah, people can run a plan, but they can't actually go out and do anything. The only problem with that is there's something called after unknowns. And so I talked about there's a dependency tree that Terraform creates that basically says, if this, then that, do this, then this. But there's certain values that can't be known until they're created. So ARNs are a classic example. And so what happens is they become what's called after unknowns. And so if you look in a plan file for any resource, there's a block that says after unknown. And if that value is true, basically it's not in that plan. It's not going to be a value that's in that plan. And so if you have a rule that says AMI value must equal this, but the AMI value is not in the plan, bad example because it will always have to be, but certain things wouldn't be, you can basically bypass those checks. And this is something that came up in an actual project, and we brought it to HashiCorp. Again, apologies. And they didn't really have an answer to it because it wasn't in their threat model for how people use Sentinel or how to address this. So it's just kind of a gap in their tooling if you run things post-plan, pre-apply. So you have to have explicit checks for anything after unknown if you don't want to allow after unknowns, which is a huge pain in the butt because in every one of your rules now, you have to say this value cannot be after unknown by checking this block and saying, if it's true or false. So if you have rules that are checking for a value and you can force something to be after unknown, which is really simple, if you add like a random ID, a random string that's computed at the apply time, and you want to bypass that rule, you just do that and then it'll be after unknown. If you don't have an explicit check, then you can just bypass that. So talking about some solutions before hopefully we can do these labs.
I wasn't getting anywhere.
Yeah. So what are some solutions to these issues? Because I say at the beginning, I'm a big fan of Terraform. It's a great tool, but then I crap on it for about an hour. But you just have to build your security tooling kind of around the whole stack. It really is an entire stack that you have to think about when using these kind of tools. And it's true for any CI/CD tool, if it's an app CI/CD or it's infrastructure. CloudFormation has some of the same issues, so you're not avoiding it using a different tool. You're going to have to build these things in layers so that you can make sure that you have checks at all the different areas that you need security. I think the big one obviously starts with IAM. If you don't have segmentation in your IAM policies for your CI/CD, that's probably the biggest mistake right there. If everyone has the same role for their Terraform pipeline, and that can do pretty much anything in the environment, that's the biggest mistake right there. So you have to work really hard to kind of rein that in and give it the least amount of privileges as possible. If you're not provisioning IAM through your pipeline, don't give it IAM access, obviously. If you're not changing security groups through that, make sure that you're not giving that access. So, yeah.
Do you find that traditional IAM teams manage that, or is it more the cloud team that manages it?
I've seen a mix of both. It's mostly been centralized teams and not like developers. You can use something like Sentinel to allow people to create rules and policies, but these tools aren't great at parsing JSON, to be honest. Like if you want to write IAM, you're going to be writing JSON and then using a tool to parse JSON and go down a tree of JSON to figure out what you're doing. You can do some basic stuff with it, but it's not. I wouldn't say it's the right tool for that. So. And then the last thing, you want to make sure that you're monitoring changes for these roles. So if you see new services popping up on your Terraform role that you're not actually using or you didn't expect, obviously something's happening either mistakenly or intentionally someone's doing something malicious. So another thing to do before you start using Terraform, before you start onboarding services to it, is thinking about the patterns of how you want to adopt services. So if you're going to use RDS, how do you want to use RDS? What does that look like? Where does that instance end up? What subnet? What security group? How are you doing IAM? And that leads into basically creating those guardrails in something like Sentinel or SemGrep or grep if you're crazy and just love writing grep. It doesn't matter what the tool is that much, but you want to have those patterns that define the guardrails, and the guardrails become security controls. And that's a really powerful way to build a more locked down environment, and that's what leads to having very few findings in your CSPM if you use these tools. Yes?
Are there any existing frameworks for the guardrails that people can kind of look at as a template?
There's some architecture frameworks, yeah. I mean, AWS has their own kind of opinion on things, but it's very contingent on your environment and how you all build things. So
FYI, I got it working on mine with tethering.
okay.
Because of that, or we can cut it over and you can use mine for the tether.
So the other thing you can do with these tools around Terraform is building hardened services. So what does that mean? Every resource, SQS might have 4 security settings, making sure it's encrypted, making sure login's turned on, making sure the access policy is locked down so it's not public. But something like RDS, in the implementations we've done, RDS might have 50 rules, Sentinel rules or SemGrep. EKS is going to have 70 to 100. The more complex the service, the more rules you have to build. So you build those patterns, you say how we're going to use it, then you harden the service to make sure you have that secure config. Then you use some tool like HashiCorp Sentinel to basically secure it. Have things like logging and auditing, have encryption, etc. And then you do want to do code review. I kind of talked about this with SemGrep, but you do want to do code review. Again, I think we struggle. We can't be this person who does hands-on code review on everything. We have to rely on our tools. So you definitely want to have something in your CI/CD pipeline, monitoring your Terraform, looking for some of these bad practices. I think SemGrep's a great place to start. My opinion is any reasonably sized company is going to need their own security engineering team at some point to build this and customize it for their environment, because no out-of-the-box solution really despite what vendors may say, really works. So you're going to eventually start tuning these rules, making it customized for you for how to do code review in an automated fashion. And then monitoring. Again, I kind of talked about this, but you really want to watch what your Terraform environment is doing. If you start seeing the role that Terraform uses deploying into a region that you don't expect or an account you don't expect, that should throw some flags up to say something's going wrong and it's acting out of the way we expect it to act. So monitor the roles it uses, monitor the environment that it touches, all those kinds of things. So conclusions, try to get these labs working, but in terms of the slides, again, I joke and I like to criticize HashiCorp because they definitely have their flaws, but it is a great tool. I'm a big fan of it compared to other solutions out there. Very easy to get started. It's a great thing to centralize on for your company to have a standardized way of deploying out your infrastructure. As a security person, you definitely need to learn Terraform. You need to learn how it works, how, as we kind of talked about, what the model looks like. Figure out a way to integrate your security controls into your pipelines as soon as possible. You don't have to have hundreds of rules. You can start with a very basic set to make sure, RDS isn't public, control planes aren't public, things like that. And you have to make sure you have your, multiple layers of controls and your monitoring, all of that. Yes, sir.
Do you have book recommendations or class recommendations on how to get smart on it fast?
There's a ton of Terraform books out there. I mean, any developer book on Terraform is pretty good. I think Terraform.
On the security aspect specifically?
Not really, no. That part, no, unfortunately.
Start right.
Yeah, so. Well, thank you. Sorry the labs aren't working yet, but we'll hang around and try to get them working. If anyone gets it loaded up, I can come over and help you kind of work through things. If you want to talk.
Do you want to use my laptop and try to demo them?
Yeah, sure, I'll do that. But if anyone has any questions, feel free to reach out on X or Twitter, McCabe615, Mike at cloudsecuritypartners.com. If you want to hear me rant for more time, I'm on a podcast called Relating to DevSecOps where we talk about a lot of this stuff. So open for any conversations, and we'll try to get these demos and labs working in a few minutes.